So let's suppose that we've got this logic diagram that we want to see if we can simplify it all. And you might be able to eventually get the ability to kind of look at this and see stuff that can just get cut away. But right now we want to look at this mathematically. So we can actually kind of read this off and just figure out how to get our Boolean expression for z. Right, and remember that our signals are kind of flowing that way, and that's also the way we should kind of read it. So we've got A and B. So remember, if there's no symbol, it's implied that there's an and there. So we've got A and B, and then that gets ORed with B. And then let's take the output of that OR gate and put in parentheses. That whole thing gets ANDed with, so this is C and this is C naught. So that's, I'll say, Z equals. I put the Z equals on there, but really we're just working with the expression part because this can be reduced and it's just representing our output. And let's see what kind of steps we can do. Well, we could start distributing some things. Let's just do that. You might immediately see that there might be something else that we can do, but I'm just going to say that first we're going to distribute this this C naught. So let's do that. So that means we've got A, B, C naught, ORed with B, C naught. So in this case, it works just kind of like multiplication, right? All right. And so the next step we're going to see is we did something goofy because we kind of actually want to factor stuff out, not factor stuff in. So this was kind of a goofy step, but it's whatever, right? It kind of helps us see what's going on in the problem. And we see here that we've got this term in common here. We've got BC naught and BC naught. So let's factor these BC naughts out. You can kind of treat it like it's one variable when if you bunch it together, but just know that it's also actually BC naught. So I'm going to put this one on the front. I'm going to say we've got BC naught, and that's going to be ANDed with the term A. And since we factored this whole thing out here, we also have to assume that it's ANDed with a 1, right? Whenever you AND something with a 1, it doesn't actually change anything. Same with like multiplying by a 1, right? When you factor stuff out, it's the same way. So that means we've got A or 1, because this 1 is left behind, and this A is left behind when we factor out. And now we know that from theorem 2 that A ORed with 1 is always going to be a 1. So this just reduces to a 1. So we'll just kind of cut it out. And that means Z simplifies to B C naught. So let's, or this is B. So when I say B C naught, what I really mean is B and C naught. But normally we just read these terms as B C naught. So let's draw what our simplified circuit looks like. We've got an AND gate and a NOT gate. So here's B and here's C. And our output is Z. So interestingly, it looks like A doesn't actually have any effect on Z. It doesn't even really matter. So we took 1, 2, 3, 4 gates and brought it down to 2 gates. So that's just kind of the use of Boolean algebra.